Hi everyone, this is Kyle Welch with RCI Wireless News. And on today's webinar, we'll be talking with Tom Elliott, Senior Product Manager at Enritsu. We'll be talking about RF testing, which includes including manual testing of in-building DAS and automation of the RF testing process. At this time, I'd now like to hand the presentation over to Tom to start the discussion on RF testing.
Hi there, I'm Tom, as Cal mentioned, and I'd like to talk today about automated in-building wireless RF testing. And the real reason we want to automate this sort of thing, besides speeding up the process, is increasing the reliability. Now, before we get into how the automation occurs, I'd like to spend just a few minutes reviewing what's perhaps some basics on what sort of RF testing is required for in-building testing. And this basically falls into two categories as far as the physical layer tests go. And there's line sweeping, and this measures the quality of the transmission lines and or the antenna systems. And then there's passive intermodulation test, which measures RF signals that may mix in the system and interfere with the received quality of the RF wireless system. There are other tests done in a DAS system, of course, CW testing, coverage testing, and things like that. But today what I'd like to do is focus on what's some of the most painful part of the testing, and that would be all the tests necessary for the various passive electrical components. So just a little bit about line sweep. I know many of you are familiar with line sweep, but to make sure we're all on the same page, the purpose of line sweep is to measure the quality of transmission lines and the cables, the antennas, the splitters in our passive system are parts of a transmission line. Okay, we need to check for things like an impedance mismatch, reflective events, cable loss, and more. And also this helps us locate faults for troubleshooting. Almost the entirety of a passive DAS needs to be line swept. In a hybrid DAS, of course, the RF parts need to be line swept. Okay. When do we need to sweep? The biggest reason for sweeping a DAS system, or a tower for that matter, is when cables are built on site. If they're installed, clamped down, connected, connectorized on site, they haven't been tested. They need to be tested, and that's what line sweep's all about. It's looking for connector quality, connection quality, dense, minimum bend radius, foreign objects in the cable. And the damage will show up as a high return loss, a high insertion loss, and can be located perhaps with a distance default. As far as PIM goes, I'm sure you've been hearing a lot about passive intermodulation testing these days. And again, the entirety of a passive DAS needs to be checked for PIM and the RF components of a hybrid DAS. But PIM is a concern in any passive section of a DAS. But PIM gets a little worse than that. PIM's also a concern from objects outside of your antenna system. In other words, the structure, the steel, the metal, the ferrous objects that are near your antenna can also cause PIM. So when is PIM a problem? You don't have to have perfect no PIM systems. You just have to have a PIM system that doesn't interfere with your uplink, okay? So if PIM falls into the uplink bands, or when the PIM magnitude is above the received noise floor, PIM needs to be dealt with because it's degrading your system. So a little bit of PIM concepts here. PIM is created when you have some sort of a non-linear device. This can be a diode. This can be a transistor. This can be rust. Now, if you think back, a diode junction is some silicon with some impurities in it. Now, if you get other things with impurities in it, they also have this logarithmic response between current and voltage. Rust, it's called the rusty bolt effect quite often. It can come from, and when you have this nonlinear effect, PIM products can be generated. It can come from 7/16 connectors that have been not tightened far enough, or perhaps have been over-tightened and then torqued. At any rate, the connector's loose. Damaged, poorly made components can generate PIM. Copper shavings inside the cable after the connector has been attached can cause PIM because there's little loose connections there. Arcing across air gaps or cracks, poor termination, but the biggest deal here is oxide layers on a metal surface. And this is where the external PIM comes from. And the fact that a DAS antenna system can have external PIM leads us to our next slide. Okay, so do I need to test PIM in all bands? If I'm creating a neutral host DAS system and it's running from roughly 700 megahertz to 2700 megahertz, do I need to test every band I've got? Well, here at Inritsu, we've done some experimenting. I was showing you a graph of the results here, and it turns out that faults don't tend to have dropouts with frequencies. If you're in the lowest band, they tend to be adapter issues. If you're in the highest end of the band, they tend to be splitter issues, but they don't tend to have dropouts. So what Inritsu is recommending is you do one low band test and one high band test for a neutral host DAS system. It's not too picky just which high band you choose. You notice there's a big gap between the low bands and the high bands, at least here in the US, in Europe as well. But if you have a choice, go for one of the higher ones, okay? Then there's external PIM. The picture you see here is a real interesting experiment. That red pole on the left has a diode, just a diode taped up to it. And there's an indoor antenna on the other pole, and we have a PIM tester there hooked up to the antenna, and we're moving the pole away from the diode, and we're checking for external PIM external to the antenna at various frequencies. This was eye-opening for me. PIM is very, very sensitive to the position of the antenna. Moving the antenna 2 feet produced a 60 dB drop in PIM. 60 dB. That tells me if you have your antenna in the wrong place, it can be impossible to pass PIM. A small change in where it's located, like in a typical office environment, move it a foot or two to one side, and you'll have no problem at all. This is something that's really worth keeping in mind when you're installing a DAS system and when you're testing for PIM. Antenna location is critical. Another issue that's very important is the antenna power. If you're used to testing a macro site, you're probably thinking, well, I'm going to do my PIM testing at 2 times 20 watts, and I have half a mile in front of me before I hit anything that's metal, and I'll just go and test my antennas and make sure they're really good. Well, when you're indoor, you don't have that luxury of the half a mile or the 100 feet or even the 5 feet between your antenna and anything metal. So it's important that you test at realistic power levels coming out of the antenna. Whatever power level you expect to be at that antenna when you're operating the system is approximately the power level you should be running your PIM test at. Going even as much as 5 dB higher than that can make it impossible to pass a PIM test. So please test your system at a realistic power level when you're doing DAS systems with an antenna. Now, if you're testing a passive network with PIM loads, feel free. Jack the power up. That's what you should do. That gives you margin. But the antenna and the external PIM is going to be a limiting factor. Okay? Now we come to the biggest deal with DAS testing, and that's scaling. Okay? When we were rolling out towers all over the world, typically there might be 25, 50, 100, maybe even 150 traces. These could be handled manually with software tools like line sweep tools, where we go through and one at a time, we look at the traces, we make sure the titles, the subtitles are proper, we make sure the limit lines are where they're supposed to be, and all that stuff. When we start talking about DAS systems, it goes up by several orders of magnitudes. We could need 1,000 traces. We could need 15,000 traces. I've even assisted with some football stadiums where it's over 15,000 traces. When you go to a neutral host DAS system, they'll require one set of traces for each frequency band. So what happens here? If we do the conventional, let's just process this thing in line sweep tools, or let's just look at the file, it was best expressed to me one day by a guy that worked for a large contractor on the East Coast. I have 1,000 traces in this directory. Which ones are missing? Which ones are duplicated? Which ones are misnamed? You can see the size of the task we're talking about here. Or on the other hand, I heard of a RF engineer working for a major wireless company in the US. He had just been handed a stack, 700 pages worth of PDFs for a DAS system. Think of him standing there with 4 inches of paper in his hand. And he's going, what am I supposed to do with this? The conventional methods, they just don't scale. So what happens is, and I've seen this more than once, is the RF engineer running the testing will get all these traces. And you'll say, well, you know, my field techs are really good. I trust them. I don't have to check all these. I'm going to sample them. I'm going to test maybe 10% of these and make sure they're good. And if my sample looks good, I'm going to send it on to my customer. That's a reasonable thing, right? Given what's going on here. But here's the issue. What I've found is conventional manual methods produce maybe a 10%, maybe a 15% error rate. And we aren't talking about really carelessness on the part of the field technicians, not at all. What we're talking about is, oh, I got a phone call. Where was I now? Oh, I'd better run this test again. Or, oh, I got a phone call, or somebody's talking to me, or I had to go adjust the antenna, or who knows what. There's interruptions. There's a lot of tests here. You can lose track really easy. It's hard to do it right. You end up with a 5, 10, 15% error rate. An engineer has sampled these. He's passed them on to his end customer. The end customer has the same issue. He samples them. He samples a different 10% of the traces. Maybe he finds an unacceptably high error rate in the ones he samples, and he sends the whole thing back to the contractor. So you get this review, return, and retest cycle. And as soon as you do that, the financials of the operation go to pot. You've got delays getting paid. You've got extra cost. You've got the opportunity cost because your crew is out there working on new work. DAS testing has a scaling issue, okay? Now, just to drive this home, some of you live this and you know this very, very well. So bear with me for a minute. Others of you may not live this and may not know this quite so well. Here's a sample branch. This is a DAS branch we've got up here in the corner. It's called FBDA 13-86. It's a MIMO branch. So there's 2 fiber to bidirectional amplifiers here, one for the A side, one for the B side of the LTE MIMO system. There's 4 antennas here. They're dual port antennas, and they're all coupled up with cables and splitters, and there's 14 cables here. Now, a typical requirement for testing this, well, we might need to do some branch testing, test the entire branch with loads in place of the antennas. Probably 2 PIM test, 3 band return loss, and that's 5 tests. Then we put the antennas back on, and we'll do the same thing again with different limits, because after all, the antennas are there. In the case of the PIM, different power levels. We'll test the antennas, quite possibly be required to test the antennas by themselves. But here there's 4 antennas, so there's 20 tests there. Okay? But then the cable, there's 14 cables, and we probably need 2 PIM tests, 3 return losses, 3 cable loss, at least 1 distance default. That's 126 tests. You add those up, and there's something like 156 tests in this branch. And I've seen DAS systems with up to 250 branches. You start to see there's a scaling problem here, okay? This is a lot of tests. It's a lot of things to keep track of, and phone calls. And this technician reads them off one way. This technician reads them off another way. We need some standardization here. We need some automation. In the manufacturing world, for years, they've had test executives that control how electronic equipment is manufactured. We need something similar for DAS testing, some automated test capability. So what we're going to talk about today is something called SkyBridge Tools. And it provides one-button testing. This eliminates many of the common causes of errors and greatly reduces that error rate from 5, 10, 15% down to somewhere below 1%. The testing cost, well, the test time itself can go down by maybe 50%, maybe 70%, maybe even 90%, because the technician is no longer typing. He's no longer doing setups. He's no longer manually saving, okay? Engineering involvement is greatly reduced. There is some setup that needs to happen, but now when you have these 1,000 files and you're looking at this and going, what do I do with 1,000 files in this directory? That's already taken care of for you. It's already summarized, and the dashboards tell you what's going on. That part of the work has been eliminated. And finally, there's a report-friendly output in CSV format, one line per test, okay? Let's take a look at each one of these, okay? The one-button testing. We have some scripts, an automatic script generator here. And because you can run the script, you no longer have to recall instrument setups. You no longer have to name the file on the instrument. You no longer have to save it on the instrument. And you don't get into this, oh my gosh, I got a phone call. Where was I again? Which test was I doing? I'll start where I think I was and start saving again. So you don't get these missing, misnamed, unneeded, or duplicated traces. And best of all, the failures become obvious during the test. All this greatly reduces returns to the work site, and it tends to standardize so that the first technician, the second technician, the third technician are all doing things exactly the same, okay? In other words, we can get it right the first time. As far as engineering involvement goes, because you have such a strong field work definition with the scripting, there's no need to sort out thousands of traces afterwards. Every test is scripted, and if for any reason some of the limits have been changed during testing, the traces are judged independently from the instrument settings, and there's dashboards. These are dashboards, summarize results. They're visible to everyone with a login, okay? And this really helps you quickly sort out missing, misnamed, unnecessary, or failing traces. Another thing the dashboards give you is what traces are present, what traces are absent, what traces have passed, and what traces have failed. As soon as these traces are uploaded by the field technician, everybody can see this, including the field technician. So if there are some failures or if there are some missing traces, he immediately knows what needs to be done. Management knows it, engineering knows it, and if you wish, your end customer can know this as well. It's possible to filter, so you can only show files of interest, such as fails, or and you can see trace images to determine the cause of the failure. There's even a way of putting notes in here, so if for some reason it wasn't possible to get this trace to pass, the technician can let the engineer know without having to get into an email chain. And the reporting format can either be in a CSV, a PDF format, or you can simply download all the traces. And the CSV format gives the trace name, key values, pass-fail, and an image, one per line, and you can readily adapt this to any specific end customer format, okay? So there's a lot of flexibility there, and the cool thing is you didn't have to spend man-months creating this thing. Let's talk a little bit about how this might work in real life. We've been talking about why you'd care about it, let's talk about how you might use it. So it is a cloud-based test manager. It's accessed by a web browser. You don't have to have any particular operating system. You do need a current web browser, and to control this, you need a connection to the cloud. It's based off of Microsoft Azure, which is the same cloud system that's used by various banks in the US. It's definitely secure. You set up test on this. A technician can download test. He can put them onto a stick, and this is important because he can put these onto a USB stick. Web access is not needed at test time. Why are you putting this data system in? Some of the time it's because you don't have web access. Okay? You don't need web access when you're out there on the pointy end doing all the hard work. Okay? So the broad overview of what we're doing here is a test plan needs to be created, the test needs to be ran, and a report needs to be generated. A little bit about creation here. The test plan details which tests are required with specifications. There's test criteria. Those are usually consistent from job to job. And there's the actual components. And what a test plan is, links required criteria to components. There's a number of ways to do this. There's a wizard to assist in the process. We can even import data from IBWave Designer. This process is inherently adaptable to whatever you want to use it for. Okay. Then there's a one-button test. There's a red rectangle around a button, a magic button called Generate Easy Test Scripts. This goes to the test plan, generates the scripts. Technicians then download, execute them, and it's generally arranged so there's one script per component, so you minimize connections. There's pass-fails possible while you're still hooked up, while the test is still running. There's an auto-save. There's now no typing. There's just a minimum of button pressing in the field. The names are always correct, and there's no duplicates. You'll know if you've missed something as well. Upload is simply drag and drop, and then the traces are auto-matched, they're auto-judged, and everybody can see the results. You can get it right the first time. And then there's reporting. We talked a little bit about the reporting before, so I won't belabor that, other than there's one line per, the CSV report has one line per test with images and with key values and pass-fail. And there are some other report formats available as well. You can also store documents that you want the guys in the field to have, MOPs, statement of works, drawings. You can upload side photos or screenshots or images. Okay, so now I'm going to break out of the PowerPoint for a minute. I'm going to go over to SkyBridge here, and what you see is a test plan results. I've generated this ahead of time. It takes maybe 5 or 10 minutes. And this particular branch, we have 4 antennas. Okay, and each antenna has 3 tests. And in my world, this is FBDA 1, antenna 4, band 1, return loss antenna. Okay, and this is the criteria, the specifications I use for the test. And here's the test, the same antenna for band 2, the same antenna for band 3. Okay, there's other antennas over here. There's a branch test. This is FBDA 1. I have 3 return loss tests I've chosen to do for this one for the 3 bands. And there's a cable test. Let's scroll down a little bit here. I have 7 cables in this particular branch. And this naming scheme is a FBDA number, the next device, and how far the cable is from the FBDA. In this case, it's connected to the FBDA, it's at level 0. In this case, there's just 1 cable and 1 splitter between this current cable and the FBDA, and the next device is 03. So we call this a level and 2 ID naming scheme. At any rate, if I look in here, I'll find I have 7 tests for each cable. I've chosen to do a band 1 return loss, a band 2 return loss, a band 3 return loss, a band 1 DTF with a short on the end, a band 1 cable loss, a band 2 cable loss, and a band 3 cable loss. Exactly what you do with this depends on the requirements of the work you're doing, on the MOP, on the statement of work. What I've chosen to do here is typical and something I've seen in past jobs, okay? Also, if I look up here, you can see I have cable 0 has had 6 pass tests and 1 failed test, and cable 3 has had 6 pass tests and 1 failed test. I'll get back to that in a moment, but what I'm going to do right now is I'm going to punch a magic button here that says Generate Easy Test Scripts. I'm going to do this for the Enritsu L-Series SiteMaster. Okay. Let's say OK. I'm generating the scripts for the entire branch right now. Let me download them. Here they come in my browser. They're zipped. I'm going to give you a look inside this zip file. There's an Enritsu directory. There's a super test directory. There's FBDA1 demo job 1. That's the job I'm working on. If I look in here, I find my scripts. Did I mention I had 7 cables? There's 1, 2, 3, 4, 5, 6, 7 cable scripts. There's 1 system test here. There's 1 branch test, and here's the 4 antenna test. Okay. Now, what I'm going to do is I previously copied this over to a memory stick, and for the sake of clarity, I'm going to switch to a video we recorded this morning. And this video is exactly what happens when you put a stick into the SiteMaster. So running this thing, I'm putting the stick into the SiteMaster. Okay, I get a pop-up here. I'm going to press the continue button. Okay, and there's our antenna, branch, cable, and system test. I'll select cable, press enter. I didn't press quite hard enough, so I'm going to have to press enter again. Okay, and now here's our 7 cable test. I'm going to select one of those, the second one. I'm going to go test a cable. We're recalling a file down here, okay? And when we're done recalling a file, this will start sweeping. And, okay, it's sweeping. There's our limit line. We're going from 698 to 960 megahertz. And pretty soon I'm going to press a button just off screen over here. It's the next button. It's the same as the software next button up here. Okay. It's press the button. We've saved that file. We've recalled the next file. We're going from 698 to 2200. We're taking another sweep. We're going to press the next button. And now what we're doing is I want to create a fail here. So you can see what a fail looks like. And I'm doing that by loosening up the cable and turning it from a load to a short. That's definitely going to generate a fail. I'll press the next button. Okay. I'll loosen that up a little bit, or tighten it, I guess. And now I'm going to distance default, and I have a marker to the max. That was part of the script. We're saving that file to the memory stick. Okay. Recalling the next file, that was the DTF return loss. Okay. Now we're going to a cable loss, and we're going to 698 to 960 again. As soon as that sweeps, we'll push the next button. We're recalling a file down here. And we're going to go to our next frequency band, which is 1695 to 2200. And we'll save it and press the next button. We'll go to the next band, which is 2200 to 2700. Okay. Now, as soon as we save that one, just by pressing the next button, The instrument's going to come back and tell us it's finished testing this cable. Saving the file, the easy test for this cable is completed. Okay. And look right up over here. You can see when we tested that cable and the cable before it. Okay, so now what I'm going to do is I'm going to take the files I got from that stick. I'm going to plug it into here. I haven't done this yet. And here's now a directory called Enritsu where our files were. And here's one new one called results for FBDA1 demo job 1. Now look in here, and here's the 7 files that we recorded in that video. I'll select them. I'll drag them over here. And they're being uploaded. It's processing. Okay, so now we have 12 have passed, 3 have failed, 0 are merely present. There's some 46 test absent here. I'll go down to here. And here's my test. So I'll look over here. And here's one of our failures. It was definitely a failure. We can see the upper limit failed here. Okay, expected 18.5, got 14.5, 1.45. Here's one of our passes. Okay. And not only can you see that it passed, but you can see exactly what it was happy with. In the case of the fail, you can see what it was unhappy with. So the next thing we do is we can generate a CSV report. And when I generate this report, it'll come back in a moment. I can download a zip file. And what I need to do now is I need to unzip all this stuff. I will do that simply by creating a new folder, opening it, and I'll drag everything from this zip file off over to the unzipped file. Quickest way to unzip ever, okay? So here is a bunch of PDFs, all the various traces I have up here, and down the bottom is a CSV. Open up that CSV, and I'll arrange the columns. So here's all the various test names, all the various cable names, I should say. If I look here, all of this is one particular cable, and these are the 7 tests we did for that one particular cable, okay? Cable 03, the band 1, 2, and 3 cable loss. There's the 3 return losses, and there's the DTF. Here's how far it was to the peak. That's the as-built length of the cable. Here's our peak amplitude. If you divide that by 2, you've got the cable loss, which is what we did here. And we actually judged against a calculated cable loss that takes the cable spec and the measured cable length to decide whether it was a pass-fail. Here is a return loss, which is passed. Here's all our pass-fails here. We got a lot of fails down here. Let's take a look at one of the passes over here. If I double-click on this thing, I actually get a PDF. And here is my image. Here's everything that passed, all the measurements. If I double click on this fail over here, I can also find out what failed. There's a red X in front of upper limit. Expected 18.5, got 1.45. So that is the CSV report. And this is the SkyBridge interface, okay? Okay. So SkyBridge has been rolled out. It's been used in a variety of locations. And Mark's Legion, a contractor for a large contractor on the East Coast. States he realized a 70% reduction in test times installing a DAS system. He points out that SkyBridge Tools has added flexibility to his staffing decisions. He has a wider variety of expertise to choose from and be confident that the test results are consistent. Mark Legion also points out that with LTE and MIMO systems, DAS complexity and density has greatly increased along with demand for line sweep detail. It's daunting, it's difficult to manage these large amounts of traces during a project. The DAS industry as a whole needs a powerful trace management tool. Thankfully, we have SkyBridge Tools. This is one of our first users, and this is his conclusion as to how useful SkyBridge Tools was for him. I'll leave you with that thought. But for DAS testing, and SkyBridge Tools is accurate. It's got one-button testing. It can reduce test cost. From our trials, up to 70% reduction in test time, less time reviewing results, and importantly, less hotel time. Everybody knows the current status, and the output's report friendly. So thank you for your attention, and let's open this up for questions.
All right, thanks, Tom. And we've had a few questions come in. If anyone has any other questions at all, submit them via the Q&A tab. All right, the first question we got in is, what power levels do you recommend for PIM and DAS testing?
So if you're testing a branch with PIM loads on the end, go ahead and test it 2 times 20. There's attenuation in the system, and using the higher levels will help ensure that everything is really good and there's lots of margin. But if you're testing with antennas out there, there's environmental PIM to worry about. You need to select a level of PIM power that's roughly corresponds to the power you intend to be injecting into the branch. You need to have the PIM power at the antenna comparable to what the antenna is going to be emitting in real life. And the reason for this is in a DAS system, inevitably, there is metal near the antenna. And as we pointed out, moving an antenna as little as 2 feet can dramatically reduce PIM, but it's also just as sensitive to power levels. If you just simply translate macro system practice over to testing a PIM branch with an antenna on the end, you are not going to get a pass. Okay?
All right, sounds good. Next question we had come in is, how does one set up a test plan? In the web browser example you showed of SiteMaster, you showed there were file names already present. How did you put that into the test plan?
There's 2 ways you can do this, and I must admit I passed by that for the sake of brevity in this one, but I'd be glad to demonstrate this later to you one-on-one. There's 2 ways to do it, and one is there's a IBWave import wizard. And what this does, it will go through the IBWave cable routing report. It recognizes certain keywords in there like FBDA or cable or splitter or antenna. And it will pull the test plan out of there, and it will match it up with test criteria that you define. And that's the way this particular test plan was generated. If you didn't use IBWave on the system for some reason, or if you're doing something like a tower perhaps, these can also be generated in Excel, and that will give you the maximum flexibility. In Excel, it basically says, here's a part number, here's what I want to call it, and here's the name of the criteria, the tests that go with it.
Okay, thank you. Next, can SkyBridge be used for tower work as well?
Absolutely. It's actually been received pretty well by some of the tower guys that I've been talking to last week. And the beautiful thing about it is once you set it up for one tower, it can be readily copied to a new tower with just changing a few names.
Okay, gotcha. So what is the sensitivity of the PIM tester? Do you try to target the -180 dBc PIM connectors?
That's past sensitivity of the PIM tester. I'm not the strongest on the PIM tester. I've just seen areas around minus 160 dBc, but I well could be wrong on that. Okay.
Okay. Can someone upload a screenshot pretty easily to the SkyBridge?
Absolutely. Screenshots, images, almost anything can be uploaded except for executable files. That would be a security issue.
Yeah, that makes sense. Next question, is there a way to check the propagation velocity and the calibration info within SkyBridge?
Yes, there is. Some of the details, matter of fact, if I go back to where I was, go over to details here, scroll down a little bit. Here's some detail. Here's the cal status, markers, parameters, and this is the sort of stuff you were talking about. Some details. It's pretty much all there. And it's also quite possible to download the zip file and do it the conventional way in line sweep tools as well, although I don't think that would be necessary.
All right, looks like we have one more question. If anyone has any more, please let me know. Actually, we just got one in. Can someone pass the pass-fail criteria based on propagation velocity or calibration?
I'm not quite sure I understand the question, but calibration off is definitely a fail. The propagation velocity is set in the test criteria and is part of the setup. So when they go to run the easy test, that's set automatically.
Okay, great. Thank you for that. Next question. In your experience, what are some of the biggest sources of RF interference you have come across?
Oh boy. Let's see. Of course, there's environmental PIM. There's commercial consumer grade equipment that's failed. There's PIM coming from neighboring cell sites, but one of the biggest ones I see, and one that consistently gets people, is there's an impression people have that interference needs to be in my channel, my uplink channel, before it's an issue. And while it's certainly an issue if it's in your uplink channel, if it's in your uplink band, if it's getting past your receiver pre-filters and get into your receiver, it can desense the receiver. And I've seen people hunt for interference for months with a strong signal just outside their channel, not understanding that was messing up the receiver. So if there's one tip I'd give you on interference, it would be that.
Okay, thanks. Another question back to SkyBridge. So the CSV file that exports from SkyBridge, can you talk about what level of customization is available in that report?
So there's several different types of output formats we can do, but what goes in there is driven by your test plan, and it's pretty well infinite. And by the time it gets to the CSV report as far as formatting, well, what can Excel do? I mean, it can do a lot, right? That's why it's a CSV file.
Okay, thanks. That looks to be, okay, one more question just came in. Is the branch test, for the branch test, what size loads do you suggest?
If you're doing the return loss on a branch test, of course, a normal precision load that's used for return loss will work. But you're much more likely to be doing PIM testing. And if you're doing PIM testing, of course, you've got to use a high power load, a PIM load. And frankly, the PIM loads work just fine for return loss as well.
Okay, thanks. It's about all the time we have for today's webinar. Actually, we can take one more question. We just got one in. Does Alda and Ritsu sweep gears, are they also compatible with SkyBridge?
All current sweep gear, all current PIM gear are compatible with SkyBridge.
Perfect. All right, thank you. That's about all the time and questions we have for today. Again, thank you for everyone for joining today's webinar, Automated In-Building Wireless RF Testing for Maximum Reliability. Again, our presenter today was Tom Elliott, Senior Product Manager at Enritsu. Thank you, Tom.
You're welcome. Thank you, Kyle.